Okay, once again, good morning. Yes, in the previous class, we have started discussing the process control. In the process control, we have started with discussing the process IDs. What is the meaning of process ID? Why it is required? Whether it is non-zero, zero, for which process we'll assign 0, 1, 2, how the numbers are allocated. Then, then we have discussed. Um, which is the function which is being used to create the process. The function name is fork, and what is the return type of that, how the fork will create the process, what is the return values, and with the example, with some program I have shown with the output. And later we have discussed the V fork. What is the difference between fork and the V fork? In the V fork, it guarantees that the child process first executes, then the parent process. Then we have discussed this exit function. Exit function is nothing but in order to come out from the process, the process has to terminate. When the process gets terminate, because it can be two ways. One is the normal termination and another is abnormal. The normal termination is the entire program is completed. At the end of the main, there is a return statement. That is why the program will terminate, or else you explicitly will call the exit function. Exit within the brackets, small brackets, you will write. When you call that exit function, exit handlers are called. How the exit handlers are called? Those functions that are registered with the at exit function. Those functions which are registered with the at exit function. This at exit function that we have discussed in the previous class, you can refer that. Those functions that is going to be executed, they are called as the exit handlers. And another function is there, underscore exit. This function, it will be uh, called, but exit handlers are not called. Exit handlers are not called here. Directly the control will return. Finally, the process gets terminated. Still another normal terminations are there. Threats which are being created. I assume that you know about the threats. The threats, assume that a process has created 5 threads. The last thread, from the last thread, when it sees the return statement, then also it is going to exit. That will also come under the normal termination. In the same way, p thread underscore exit function is there. For threads, there is an exit function, p thread underscore exit. If that function it will be seen, in that case also the process gets terminated. These are all come under the normal termination. Abnormal is as there is a signal which has been gets generated, SIGABRT, signal abort. When the signals get generated without doing anything, the process gets terminated. Or any other signals. Other than this, any other signals which are related to the termination, if it is been seen, then the process gets terminated. These are all the exit functions. The next we have to discuss about this wait and wait PID function. This wait function, why this is required? The first question is wait, why this function is required is the child has terminated. Parent wants to know what is the termination status of that child process. Whether it is an abnormal termination, whether it is a normal termination, what resources it has used previously, it wants to know about its child. If it wants to know about this child, then the parent process, what it will do is, it will call this wait function. Then from that wait function, it will get the information. That's all. All these next, totally we'll discuss some 4 to 5 wait functions. A small difference is there. The main intention is this itself. It wants to know about the child. Wow. What is the termination status of the child? How does the parent process will came to know the child has terminated? That is the question. The kernel, when the child process gets terminated, it will send a signal. The signal name is SIGCHLD, signal child signal. It is just a small information. That small information, the kernel will send it to the parent process. Oh, that indicates, oh, child that gets terminated. See, this child and parent process, both the process will do its their own work. During the child termination, the parent process may do some other work. That is why the termination of the child process, that we call it as an asynchronous event. It is both the process will not wait until the other process completes. That is why it is asynchronous. That is why this signal mechanism is required. Every time when the child process gets terminated, the SIG signal will come to the parent process. What the parent's process should do? It will take some action. What is the default action? Default action means if it does not do anything, ignore. It will ignore the that signal. Means it is not going to do any actions. The default action is written like that. It is not going to do any actions. Or else, when it sees the signal, then what parent process will do is it will call the wait function. With the help of the wait function, it can get the information about the child termination status. I think this is clear. What is the meaning of the wait function? See what the process can do with this wait and wait PID. When the parent process has called the wait function, assume that the parent process has called the wait function, but the child has not completed its work. It has not terminated itself. Still, it is running. But the parent process in the urgent, it has called the wait function. Then what it will do is it will block. Means it will halt. It will wait for some time until it gets terminated. Or else the child has terminated. Then when the parent process call the wait function, it will return the termination status of the child. Okay, normally it has terminated some number, it is going to return. Or else the child process is not there, but the parent process in urgent, it has called this wait function. In that case, it immediately returns with an error. These are the three possible cases with when the process call the wait function. It can block because it has still the child has not completed his work, it has not terminated. One more, okay, it has terminated. At the right time, the parent process has called the wait function. It will return the termination status. One more case, the child process is not there, but still the parent process has called the wait function. In that case, it will return with the error. See, this is the function PID underscore T wait, PID underscore T wait PID. These are the two functions. These two functions, they have been in the header file called system sys.wait.h, sys.types.h. It is inside that header file. You see the arguments there, int, stat, location. It's a pointer. The second one also, wait integer, process ID, stat, stat, location, int options. Process ID that you already know, you want to know about which child process, that process ID, PID you have to pass. What is this stat location is? It is going to, it is an address, this is a pointer to an integer. The stat location is, it's a pointer to the integer, which will give you the termination status. In that location, the termination status will be stored. The status location, it is nothing but it's a pointer. Pointer is nothing but it's an address. That address, if you go to that location, you will get the value. What is that value? It is the termination status of the child. Then, what about these options? This option is at what time it is terminated. It is a type of the termination that you want to know. That is this option. Therefore, the status location, if it is an pointer to an integer, if it is not a null pointer, then if you go to that location, you will get the termination status. What all the informations that you are going to get is the exit status you are going to get. From that integer, you are going to get the exit status, how the child process has exit, whether it is from the main function or whether it is from the explicitly exit function is called, or explicitly underscore exit is called, or some signal about signal is called. So it can be any reason. That information you are going to get in the exit status. What type of the signal number the signal has received, or and also the some temporary files, that generation of the core file, that information you are going to get. You are going to get it from the second parameter called stat location. There are some macros. Macros you can call it as the function itself. If you pass the values to this, if you give the status, the termination status to these macros, you are going to get to know what about this termination status. Which are those macros? WIF exited. This is one macros. WIF signaled. WIF stopped. WIF continued. In this way, there are four. In this way, there are four macros are there. These macros, if you pass the value to this, how? Like this. I'll show the example also. See, the WIF exited. What I am passing here, I am passing the status. What is the status? This is the exit status. This is the exit status of the program. If you pass to this, if it returns true, if this function returns true, it indicates it's a normal termination of the child. And what is the exit status number? Exit status is 7. If the status, if it is WF signaled, then it indicates it's an abnormal termination. If it's an abnormal termination, the signal number is 6. In this case, one more, we are going to check whether if core dump, there is a function called core dump is there, what this will return, when it will return to is, if the temporary, that core file is gets generated. If whether the child process is currently stopped, if you want to check, then you pass that status to this WIF stopped. In this way, you have to pass WIF stopped. If you pass the status, the child was stopped. What is the signal number it has stopped? That you can check. This is that is why instead of function, we are calling it as a macros. Even you can call it as a function. These functions, you have to pass the status. If you pass the status, then you will get about the child termination status, whether it is a normal termination, abnormal termination, whether the core file gets generated or the child was explicitly stopped or not. That information you are going to get. There is one more function called the wait PID. Here you have seen there are two functions are there. One is wait, another one is wait PID. This wait PID here, I'll show with the example. First, you want to know this the difference of this wait and this wait PID. When this function we are going to use is the child has not gets terminated. Child has not get terminated, but the process is going to call the wait function. The parent process has called the wait function. If we do like that, What are the three options I have before I have said whether it is going to block or not, block or immediately it is going to return you the termination status or it will return with the error. If you don't want to block, if you don't want to block, then you will go for this wait PID. The wait PID, it is this function which will does not wait for the child to get terminated. It has some other options. It has some other options that will control the process. Is it clear? That is why there is a third option called the third argument. There is a options. It has a number of options that will control which process it waits for. That is the main difference. Wait PID and wait. Wait PID is it is going to block until the process gets terminated, or else it will return the status or it will return the error. The three possible cases. What the wait PID will do is if the child has not gets terminated, some other informations, some other information that we are going to get from the calling process, it is not going to wait for the child. It is not going to wait for the child. What is that options is, see, there are so many, still that the PID is there, right? Some PID argument. That PID argument, what you are going to give? If you give for -1, it waits for any child process. See, this the argument, wait PID argument, in that PID is there, right? The first argument. The status location is it's an address which contains uh, the termination status, the exit status, the signal number, and also whether the core file has gets generated. What is this first argument in the PID? The first, and what about the return type of this? The return type is the which process ID it has been terminated. That will be the return type. What is this PID is? What we have to pass is if you pass for the -1, then it waits for any child. If you pass it as greater than 0, means any other number, wait for the child where that process ID equals PID. Means if you pass it as 22, then it will search for the process ID 22 and then it will execute. What about if the PID is 0, then whose process group ID is equal to that calling process? There will be a group of process. There will be a group of process. For that, there will be a unique ID for that is called as a process group ID. Then if that calling process group ID is 0, then it will match, then it will wait for that child. If it is less than -1, whose process group ID is equal to the absolute value of the process ID, that it is that child it is going to wait. See these numbers you have to the parent process it will pass. It is not the you, it is the parent process. It will set these values because it want this that parent process wants to know the termination status about the child. Which child it wants to know? If it wants to know about any child, then it will pass it as -1. Specific process it wants to know, it has to pass the specific ID. The second case, process group ID means 0 and less than -1. These are all the options that these are all the first argument of the PID. The wait PID, finally, you can say that in a one word, it is a non-blocking version of the wait function. This is not going to block, that's all. It will not wait. So this is one function This is one sample program where you will see the different the process creation. See, this is one example. Whenever you call the fork function, what happens? The child gets created. If the return type of that it is less than 0 means it has not successfully created the process. That is why fork error. If that return value is 0 means it indicates child has been created, and explicitly you are going to you are calling a exit function. See, you have called the exit function. You have called the exit function. Now wait function is been called. See here what we are demonstrating here is we are trying to see the output, how wait function is going to execute. But in the operating system, the parent process will do all these things. Wait and ampersand status. This status if you pass, if it is not equal to PID, it's a wait error, or else PR underscore exit function. It means it will print the status. It will print the status. What we are showing here is, see, here it is the some normal exit abort function. Abort function, if you call it, is an abnormal termination. Another type of error, divide by 0. It will 0 when it generates the floating point exception, it will throw. Floating point exception, another type of signals. In that case, what will be the status that you can get from this PR underscore exit function. This exit function, it is going to return you what type of the termination status. That you are going to get it from this wait function. See, wait ampersand status. Why this ampersand is, you should go to that address. That address, all the integer value will be there. That value, we are going to pass it for this PR underscore exit function. This function, it will print the status. The next function is wait ID function. Till now, wait ID, wait PID we have seen. One more function is there, wait ID. Uh, the wait ID and wait PID functions, it is not very specific to the child process. For that reason, they have come up with this function called wait ID. With wait ID, we have so many options. The wait ID, we have so many options. See here, you are going to give the ID separately and ID type. ID and ID type is separate. And also the signal information, and so many options are there. What is this uh, two, four arguments are? See here, whether you have to wait it for a particular process, whether you are going to wait for a particular process or the process which belongs to a particular group, or you are going to wait for any child process, a particular process, that is one case, or whether you are waiting for a child process but it belongs to a one group. There will be a group of process and there will be an ID for that. Whether that child, whether you are waiting for that child or you are waiting for any child, that is information that you can give in this wait ID. This minimum option, it is still there in the wait PID. It is very similar, but some extra flexibility is there. That wait ID and wait PID is almost the same, because still there also you can give -1, 0, the first argument. Some extra flexibility is there, that's all. What is the first argument for this wait ID you are going to give is P underscore PID. If you give p underscore PID means it is going to wait for a particular process. You have to give the ID. If you give p underscore PID, then you have to give a particular ID, the number 21, 22, 23. If you give for this p underscore PGID, then you have to give the process group ID. You have to give the process group ID. If you give here p underscore all, the constant p underscore all, if you return, then what happens is this value, even if you give anything 21, 25, any number, if you give, it is going to ignore it, because this wait ID, it will wait for any process. If any process gets terminated, it will return the value. That is how this works function. See these three functions: wait, wait PID, wait ID. Whenever you write in the exam or in the test, first you have to write this header file, then you have to write properly the syntax, then what is the return value, then what are all these arguments, what is the meaning of that. If you write, the maximum marks you are going to get. One by one argument you have to explain. In that way, if you explain, the maximum marks you are going to get. See, there is last field called options. There is a last field called options. That options, what you can pass is this W continued, W exited, this W O wait, W stopped. What is this indicates is some extra information you are going to get from this, whether that process was previously stopped and whether it was and it has been continued. See, all these informations you are not going to get in the wait PID, whether it was stopped and it was continued, whether it was normally exited, normal termination, or whether it was blocked after that it has resumed. All that's information. If you want to get that, then you have to pass this option at the end. See, these values, it is with the bitwise or of the flags, the numbers will be there. That numbers you have to pass this argument. This is what is not there in the wait PID. That is the main difference. If you use this wait ID function, some extra information you are going to get, that is whether it was blocked and it has come back, whether it was stopped and whether it was continued, whether it was normally exited, some other extra information you are going to get about the child. That is why uh, this function is useful, wait ID. There is one more function is there, wait 3 and wait 4. See, one more wait function. There are totally 5 wait functions are there. Wait, wait PID, wait ID, wait 3 and wait 4. If we use this function, almost the same, wait the PID function, but some extra information you are going to you are going to get, that is the resources, but provide the additional informations about the resources used by the terminator process. The child process has used the CPU time for 10 milliseconds. For 10 milliseconds, it has used the user CPU time. That another child process has used the system CPU time for another 20 milliseconds. The child process, the third child has used, it has generated the 3 signals. These informations you are not going to get in the other functions. That is why this wait 3 and wait 4 functions are used. See, the state, it's almost the same. Status location, options, it is same. But extra one structure is there. This structure, what it contains is, it contains about the resources that is being used by the child process. That information you are going to get. about the which process you want to get the information. This is what the PID you have to give -1, 0 or any less than that or any number. But if you go to this address, R usage, this is a structure address. If you go and if you check there, you will get the entire information about the resources that has been used by that child during its execution. But after that it has gets terminated. After that it has gets terminated. But you want to know about how much of user CPU time is used, how much of system CPU time is used, how much of signals are gets generated, how many core files are get generated. All that information you are going to get if you go to this location. All that information it is there inside the structure. That is why struct R usage. Remember 5 functions: wait, wait PID, wait ID, wait 3, and wait 4. In the next class, we will discuss this race condition. The race condition is since there are multiple processes, since there are multiple resources, you have to share the data. I think you know about this race condition in the operating system. Multiple processes are trying to get the same resource. All the resources are fighting for the same resource. How the data gets shared, what is the final outcome, means in which order the process has got those resources, in which order, or else if you don't properly handle the situation, if you don't properly share the resources to the processes, then the deadlock situation will arise. Then the process will not continue itself, its execution. That is why you have to handle these race conditions, how you are going to handle the data which is being shared and in which order the processes is going to run. That is what this race condition is about. That we will discuss this race condition in the next class. Thank you. If you have sent the attendance, everyone, then you can exit. If anyone has not sent the attendance, please send quickly. We have less than 1 minute. We'll end for the today's class and we'll quit in the tomorrow's class. Thank you.